We are now located at the base of site number 3. The intended use of this site is for cultivated cropland, dry land, non-irrigated. The current usage of this site is a wheat and green pea rotation. Presently, this site is in stubble. It's shortly after the harvest of the wheat in the fall of the year. If we look at the information that's given to us on the site card for site number 3, the intended use, of course, is dry land, cultivated agriculture. Our soil test results tell us that there are 12 parts per million of phosphorus in the soil at this location, 170 parts per million of potassium. Nitrogen for this location and usage of the site is said to be deficient. The pH is 6.6. We have 120 frost-free days at this location. Our average annual precipitation is 20 inches, and the original depth of the topsoil was 15 inches at this location. This is not a site that is prone to flooding or has ever flooded. So with this information, you should record it, and we'll next to use for evaluating the site. Next, we will go to the pit location to determine the characteristics of the soil profile. We're now located in the bottom of the pit for soil site number 3. What we're going to do here is similar to what we did in the other sites, and that is to evaluate the characteristics of the soil profile. I placed this red and white stake as a marker indicating where we progress from the AP, or the upper part of the topsoil, into the transitional horizon, or grade 8, into the subsoil. The topsoil at this site is very mellow, high in organic matter content. Remember, we've just produced a crop of wheat at this location. It covers a depth of approximately 10 inches at this location. So the current depth of soil at this location is 10 inches, topsoil. I placed this stake at this location because as we go below that, we begin to see a much firmer consistency in the soil, and also indicated by color, what we're getting into here is some very strong PED, or structure formation. And this is being caused by the higher content of clay that is alluviated out and been deposited at this layer in the profile. You can begin to see the staining on the soil PEDs here, that lighter colored staining being from this alluviated clay. So this is really a transitional horizon between the A and the B as we progress down through this area where staining has occurred in the soil. As we progress below that, we get into a very high clay consistence or content subsoil. This is very firm, as you can tell from the way I'm pressing on this shovel in order to even break small pieces out. So what we have here is a very loose, open, mellow topsoil. We really have somewhat of an artificial AP horizon here, in the fact that this is basically the depth or zone of cultivation for this particular site. So unlike the 2 previous soils that were non-cultivated sites, here we have a cultivated agricultural site, and we oftentimes will see the depth of the topsoil or the transitional layer occurring right at the base of the zone of cultivation. So we've marked it here at the base of the zone of cultivation, have a transitional horizon, and then a very high clay, consistent, very firm and consistent subsoil below that. So when we go through here and evaluate soil texture, what I'll do is I'll take a sample from here and a sample from down here in the subsoil so that we can look at the difference between these 2 textural groupings of soil. This has quite a lot of organic matter content in it, but I don't think it's enough to where it's going to be interfering with our textural class determination. So I'm going to wet the soil again, similar to the way I did on site number 1. Bring it up to the right moisture content, and see how well it ribbons and what the degree of stickiness or plasticity is to this soil. Getting the moisture content at just the right level is a little bit difficult to do at times. The tendency is to over-wet it. So I'm going fairly slow on this particular sample so I don't do that. Got some free moisture in my hand here. I'll now work into the ball. This soil has a fairly sticky consistency, indicating perhaps a little higher clay content than the previous silt loam surface soil that we had at site number 2. But I still believe, based upon the type of ball, the stickiness or plasticity, and the strength of how it ribbons, that it's still going to fall into the silt loam textural class, even though it has a little bit more clay than the previous location. So I'm going to place this ball that I've just formed up here so I can compare it to the subsoil when I get that one done. Now, there's always a possibility of cross-contaminating these soil samples, so I'm going to rinse my hand off here a little bit so that I don't do that. And then I'm going to take some soil from not this transitional horizon, but the true subsoil at this location. What I hope to be able to show you here is going to be the difference in consistency of the balls and the ribbons that are formed between these two soils. It's going to take me a little while to get this one broken up enough to form a good ball, because it is very firm and very consistent at this depth. Now, what effect is this very firm and consistent subsoil going to have? Well, it will have an effect upon textural class, of course, but the other thing you'll need to consider this for is the permeability of the soil at this location. This is occurring shallow enough in the profile to where we do need to consider it in terms of what effect it would have on the permeability of this soil. Now, when we're talking about permeability, we're not necessarily talking about the ability of the roots to grow through it, but we're talking more about the ability of water movement, water to move in and through this profile, as well as how well aerated this subsoil might become or would be. You'd expect with the higher clay content to have a little bit poorer aeration in the subsoil. One of the things that tells me the soil has quite a bit more clay in it is the degree of stickiness or plasticity. And although I'm getting this pretty wet, this soil is much more sticky and much more plastic than what the topsoil was at this location. This indicates to me that I've got quite a bit more clay. If I go to ribbon this soil, once I get the clods out of it, as I go to ribbon this soil is going to have a much greater stickiness or plasticity. It's going to also be able to ribbon. This ribbon would go out there and be in excess of 2 inches in length if I ribbon this out. So I've got a very high clay content subsoil here. I'm going to evaluate the topsoil at this site as being a silt loam, and this subsoil as being a silty clay or a silty clay loam. It's probably, we'll put it in the silty. I don't believe it's quite high enough to be a silty clay, so it's a silty clay loam. But definitely much higher in clay than what the topsoil is, based upon the stickiness or plasticity and the ribboning ability of this soil. So topsoil here will be a silt loam, subsoil will be a silty clay loam. So you need to place those in the appropriate textural classes and determine permeability at this location. I see no restrictions in the profile here that are going to indicate that we would restrict root growth other than the firm consistency of the subsoil, but that's not really an impermeable barrier, so we would still consider this to be a deep soil, meaning that there are not restrictions that prevent root growth or all water movement within the height of the profile here, or should be the depth of the profile that's been exposed.